Hi everyone, welcome to Kamak channel. Last time we talked about physical refining, and a lot of you asked, what about chemical refining? Well, chemical refining is like an old, reliable pro in the oil processing, and it's especially good for handling crude oil with low acid values. Today we will focus on the 3D animation and break down the whole process of batch chemical refining step by step. We will explain every detail from cloudy crude oil to pure finished oil. Finally, we will wrap up with what it's good for and its key features. Batch processing is all about handling one batch at a time. The steps are clear and easy to follow. Let's start from the beginning with the footage. Step 1. Degumming. This is the first step you see in the video. Freshly pressed crude oil has a lot of gummy stuff, like phospholipids. These things make the oil foam and smoke during heating and cooking. Look, the crude oil is firstly pumped into a degumming tank and then heated to around 60 Celsius degree, and then workers add hot water or phosphoric acid. These additives make the gum clump together into fluffy bits. Next, we stir it for a few minutes to make sure all the gum clumps up. After stopping the stirring, here's the key part, letting it sit. We have to let the oil in the tank sit quietly for a while. These fluffy gum bits will slowly sink to the bottom, forming thick brown gum sludge. Once the layers are totally clear, we open the valve at the bottom of the tank and drain the gum sludge manually. That's how degumming is done. The oil on top now has less gum and looks a bit clearer. Step 2. Alkali refining for deacidification. It uses chemical reaction to remove impurities. The degummed oil is sent to an alkali refining tank, heated to around 70 Celsius degree. Then we slowly add food-grade alkali liquid. The alkali reacts with the free fatty acids in the oil to make soap stock. Soap stock not only takes away the free fatty acids, but also soaks up some pigments and impurities. We stir it well to make sure the alkali and oil react fully, and then let it sit. We wait until all the soap stock sink to the bottom. Once the layers are sharp, we open the valve and drain the soap stock. This chemical reaction really fixes the oil's risk of going rancid. Step 3. Drying. The oil after alkali refining has a little water left. Drying here is super important to prepare for the next step. Bleaching. The oil is pumped into a vacuum drying tank, and we heat it slowly to around 90 to 105 Celsius degree. The main reason we have to dry it is because the water ruins the effectiveness of the bleaching agent. If we take white oil into the bleaching step, the activated clay can't grab the pigments well, and the bleaching won't work. Under low pressure, water turns into steam and evaporates quickly. The steam coming out of the top of the tank in the video is the water. Only when the oil is dry can the next bleaching step work well. Step 4. Bleaching. Now the oil has less impurities and no water, but it's still dark, like yellow and green from the keratin and chlorophyll. That's when the bleaching tank comes in. We add activate clay or activate carbon. Those absorbers are like strong magnets. They grab onto pigments and tiny impurities tight. After stirring for 10 minutes or so, we use a filter to strain out the clay that soaked up the impurities. Look at the oil flowing out in the video. It goes from dark yellow to bright light yellow right away. Step 5. Deodorization. The last step is to get rid of the bad smells. The bleached oil goes into a deodorization tank. We make it high vacuum inside, heated to 220 to 250 Celsius degree, and blow in a little superheated steam. Under high temperature and low pressure, the steam acts like a carrier. It takes smelly stuff out of the oil. They are pushed out the top of the tank, cooled and collected. After this step, all the rancid smell and raw oil smell are gone. Only the light, natural smell of the oil is left. Now that we have watched the whole process, let's highlight the key points. What's batch type chemical refining good for, and what makes it special? Firstly, what it's good for. It works best for most common oils except for some special high acid ones like palm oil, rice bran oil, and high acid cottonseed oil. For example, daily cooking oils like soybean oil, rapeseed oil, peanut oil, plus corn oil, sesame oil, flaxseed oil, etc. These oils have low free fatty acid levels. Using alkali refining to remove acid doesn't make much soap stock, so less oil is wasted. It is really cost effective. Also, batch equipment doesn't cost too much compared to the physical refining, and it is easy to adjust. It is perfect for small and medium oil factories, and it is simple to switch to processing different oils. So now if you want to know the difference between the continuous and batch type refining or have other oil processing questions, leave a comment below. If you like today's content, don't forget to like and save it. See you next time.